So today I'm going to present some work I did as part of a project to evaluate the non-market benefits of nutrient mitigation technologies. So there's quite a lot going on here. I'll probably have to skip over a few things, but the slides will be up on the NZ Areas website later if anyone wants to look at them in more detail, or I can always send you my draft paper. So the first thing I did for this project was actually do a really broad literature review about what is the purpose and meaning of non-market values, because it seems like we still have a lot of difficulty using them in real policy decisions. So I found the work of Mark Tadaki quite influential, where he talked about environmental management and how it's about understanding and enacting values. So while some strategic freshwater decisions are made with consultation and engagement, many operational decisions are still left to the discretion of policy administrators or stakeholders. But these operational decision makers still have an obligation and sometimes a requirement to invoke social values when deciding what programs or projects to fund in specific areas, while still balancing the priorities of iwi and other groups. So economists usually take the approach of value as a magnitude of preference. That's not the only type of value, but we tend to focus on this one. But there are different approaches even to this within the different streams of economics. So the field of environmental economics just extended the neoclassical tradition of individualism and marginalism and efficiency in GE models to analyze environmental issues. And the focus is on models that can relate environmental changes to monetized impacts on welfare. But this ignores distributional consequences and interdependencies. So ecological economists, on the other hand, believe that monetized values for the environment are socially constructed to fit the perceived role and context rather than being stable and pre-existing. And there's actually a ton of evidence to support this. And behavioral economists tell us that people don't behave as utility maximizers are expected to when they have less than perfect information, which is pretty much all the time. And then mathematicians claim that demand theory is fundamentally flawed, and apparently the only viable alternative is Marxian value theory. So it was quite a broad literature review. And I didn't actually deviate that much from a standard utilitarian approach in the end. I wasn't going to go into Marxian value theory. But I did incorporate some guidance from ecological economists. So, moving on. So the motivation for this study was to help evaluate operational decisions, such as specific restoration projects, technologies and practices. In this case, in these types of decisions, non-market values are usually left in the unable to quantify basket. So we wanted to do a bit better than that. So there are many examples of freshwater valuation studies in New Zealand. A lot of people here have done some as well. Most took the environmental economics approach, but there are some examples which are more in line with ecological economics thinking, like RIVIS or the Cultural Health Index. But I just couldn't find anything that was relevant or applicable to the operational decisions that we're looking at. There's several reasons for this. Some of them had attributes that weren't that ecologically relevant, or they weren't relevant to the decision because it was a value for a specific level of quality, where our intervention outcomes are less certain than this. Or it wasn't embedded in the right institutional context. Or it couldn't be aggregated because it was at a regional level, or it only included a subset of relevant indicators. Or it was unable to be disaggregated to a site. So the approach I took for this study was firstly to recognise that values are socially constructed. So the questions had to reflect current freshwater institutions as much as possible. In order to get around the part-hole bias problem, I separated the measurement of total willingness to pay and then decomposed values for different restoration goals. And also separated measurement of absolute attribute importance with the impacts of the levels, because there are a lot of different attributes, and we're only really interested in a small subset of those. And then I brought it all together and constructed spatial weights for every watershed in New Zealand. And this is called a hybrid valuation instrument. They're kind of rare in the literature, but there are a few interesting examples of people combining different measurement approaches and models. So the methods, I'll probably have to skip over this quite fast, but the interesting part of this is actually a technique called a budget allocation game, which was developed a couple of decades ago by political scientists. It hasn't really been used by environmental economists much, mostly because it didn't have a nice, easy model like the discrete approach. But recently, this guy called Bart has developed a multiple discrete continuous nested extreme value model, which gives us a lot more options for this type of discrete continuous decisions. And the hierarchical structure allows the evaluation of a larger number of attributes than you can in a full profile choice experiment, some of which would be usually dominated by other items. And we know that people naturally arrange their values into hierarchies anyway, and it's especially relevant when there's limited substitutability. So it's an approach that just made sense. And finally, at the lowest level, I did 3 discrete choice experiments for specific projects that would address nutrient, sediments, and pathogen contamination in waterways. So this is just an overview of the survey structure with the different parts that I mentioned before. And I just wanted to talk a little bit about how the restoration goals were structured and how we came up with those. You might notice that there are no cultural goals in here. That is because there's actually a regulatory requirement to recognise tino rangatira tanga. And I didn't really think it was appropriate to ask the general public how much to allocate to these cultural goals. Rather, iwi priorities and general social priorities are 2 separate criteria that decision makers have to balance. So the cultural side of things is outside the scope of the study. So the attributes in the choice experiment, the purpose of this was to estimate the distance decay effects and see if those were different for the 3 indicators, nutrients, sediments, and pathogens. So the quality indicators that I used came from the Land, Air and Water website. They're presented quite nicely with little quartiles rather. And the cost range came from actual funded restoration projects. And respondents were assigned only 1 of the 3 choice experiments, just because people find these repetitive choices quite boring and they didn't need to do all of them. So the results. Data collection used social media advertising again, and we got 1,685 survey completes within 10 days. And respondents were older, more educated, and more enthusiastic than the population average. But I was able to use an auxiliary variable from the general social survey to correct for this selection bias. And as it turned out, there was no need to reweight for the demographic differences because they weren't significant explanatory variables anyway. Not even income or education, surprisingly. Yeah, so the total, the contingent valuation question for an agreement to pay for restoration, people were informed of the actual Crown budget for freshwater restoration funding this year. And that was a tricky number to actually calculate by itself. I had to add up multiple programs, and I excluded the DOC funding because their primary goal was biodiversity rather than water quality, even though there will be water quality benefits. So as you might expect, people anchored on this $103 million value. Now that's not necessarily a bad thing because people are going to anchor on something anyway. I mean, values are socially constructed, so it might as well be an anchor that's actually relevant to the problem. So 30% think that the government should fund more restoration, and only 17% think funding should be cut. And that gave us a median of 188 million per year. And the most significant explanatory variable was whether the individual thinks water quality is a problem or not. So that's the question that I included from the general social survey. And among the people who want to increase funding, 40% of it want to increase taxes. The rest would rather use debt or decrease some other government budget like defence. And the people who wanted to decrease funding, they'd rather spend it on health. So I just wanted to point out that this is a willingness to pay for restoration activity, not a specific outcome, because the outcomes are kind of uncertain and they're vaguely presented as improving water quality within a lifetime or something like that. I also included a question about willingness to accept economic costs in terms of reduced GDP growth. So that was a similar story. Some people think the rule should be stronger. A few think they should be less strong. And again, that was anchored using a value that was estimated by NZIER. So most people think the economic cost is worth it. 76% do anyway. So people displayed a few different strategies when allocating their restoration budget. People who don't think it's a problem were more likely to put all of their funding into improving access or reducing contaminants, especially the rubbish and the toxicants, whereas everyone else allocated across multiple habitat and contamination categories. And very few people allocated equally, so there were some definite preferences in there. And the choice experiment results, the nested multiple discrete model fit really well. And I used the random parameter estimates to generate these distributions here. So there's a strong distance decay effect for all three indicators, but particularly for pathogens. Those values drop off pretty quickly with distance. And also for the E. coli, people have a really strong preference for restoring the worst sites first. They don't care so much about the sites in the third quartile. So to bring it all together, I calculated the distance between every rec watershed and every census area. So that was millions and millions of distance calculations. And then I used those to apply the distance decay weights. And we don't have monitored data for all of those watersheds, obviously, but I used modelled water quality data from river maps and then put those into quartiles. And then I calculated the population and distance weighted willingness to pay in each area for each of these catchments and added them all up and normalised to the total of 188 million, which was the median total willingness to pay. And the outcome is that the social benefits of restoration are highest in degraded catchments, which are closest to population centres, which is not really a surprise, but at least now it's quantified. And I just wanted to point out that there's been no adjustment for how effective the restoration would actually be in different areas. That's another factor that decision makers will have to take into account.
2 more minutes, Yvonne.
Yep, nearly there. So if you look at this at a regional level, the implications are that this chart shows the difference between if you are weighting the regions by their average quality or weighting it by social priority. You can see that if you weight it by the social values, then you'd want to put more restoration funding into the Waikato region and less into Canterbury, even though Canterbury has slightly worse average nutrient levels. So the conclusion, journal paper is nearly finished and spatial value layers will probably be used in socio-economic modelling for catchment plans and sediment guidance, and will also be included in CBAs for mitigation technologies. And for restoration activities that have impacts on multiple indicators, this might help inform what weight to give each impact. But the limitations are that it doesn't consider site-specific restoration efficacy, how effective it's going to be, or any special character or customary values. So the decision makers will still have to balance all those things, but some of those will probably have higher weight, particularly iwi priorities. And the other limitation is that the restoration priorities are quite dependent on how the hierarchy is structured. So we put a lot of effort into alternative structures there. But if you did it slightly differently, you'd probably get slightly different priorities. So yeah, that's it in a nutshell. Thanks.